Okay, so my name is Stan Yoshinobu. I'm from Cal Poly San Luis Obispo. So I'm moderating this panel session. We have 4 panelists: David Clark from SUNY New Paltz, Brian Kantz, Augustana College, Lee May, Salisbury University, and Carol Schumacher, Kenyon College. They all have in common that they've written IBL books and they've been published, and so that's wonderful. But they're not here just to for that reason. They're here because they're experienced instructors. They have mentored many new IBL instructors, and so they're here essentially to start a discussion and to answer your questions. So what the format will be, I've prepared a few questions that I'll just ask only one panelist to answer so that we have time for you later. And then after those 4 questions, we'll just open the floor up for you to ask your questions, all right? So that's how we'll do it. All right, so we'll just get started. So I'll give the first question. Could we get these on the screen to David Clark? How do you select presenters in an IBL class?
Okay. I think this is the easy question. What I want in an IBL class is to get all of the students participating and presenting, and so my goal is to have that as uniform as possible, and the way to do that is to select the student who's presented the least. So what I do what I do is at the beginning of each class, I send around a sheet of paper. So my class is usually big enough that I don't want to be guessing randomly. I send around a sheet of paper with the names down the side and the theorems across the top, and ask them to check which ones they're ready to present. So I have the information right there. And then we get to a theorem, and I look at the students who check that they are ready to present it, and I choose the one who has presented the least. And the result of that is that by the end of the semester, they've usually presented about the same number, with the stronger students presenting harder ones and other students presenting easier ones.
Thank you, David. All right, question 2 goes to Lee. What do you do when you notice some students in your class are quiet or passive for, say, an extended period of time?
If I don't know well what a student who seems reluctant to participate, then I take a passive response. That is, I wait for him or her to make the first move. If a considerable amount of time goes on and the probability of this student's coming forward is approaching 0 or is still at 0, then I'll probably speak to him or her in private. When I do so, I try not to appear threatening, just curious. I've noticed that you haven't said much in class and you haven't volunteered to put up any of the solutions on the board. I just wondered if there was anything that you'd like to share with me about why you haven't been a little more active in the course. And usually the student will open up right away and say that he or she just doesn't feel confident, or is maybe just a day behind being ready to present. And we can usually work out of that a constructive, not only dialogue, but a plan for that person to begin to get more involved in the course. Sometimes it would be the students coming to my office when he or she has something that might be a good thing to present, but isn't sure and wants to kind of run it by me first. And I won't necessarily say, well, what you've got there is right, but I'll say, I think that's definitely worth presenting. And the students, I think, know that I'm not saying that it's right when I say that, but they at least think that I think they have enough of interest to say that that gives them the courage to come on up and present their work to the rest of the students. But in general, I give the students lots of time to survey what's going on among the rest of the students before they want to jump in by themselves. And then I let nature take its course, and I handle it on a case-by-case basis.
All right, thank you, Lee. We'll just go down the panel. So I guess, Brian, you know who you're after now, based on the pattern. All right, so question 3 goes to Carol Schumacher. What do you do when no one has anything to present?
Oh, yeah, he gave me the hard one, didn't he?
Yeah.
In most of the courses that I teach using IBL, I've taught them quite a bit by now, and so I'm almost always aware before it happens of when students are not going to have something to present. When I teach a course in the fall that I haven't taught before, I won't really necessarily know that. But so when I kind of know that it's likely they're going to run into trouble with something, I prepare some sort of maybe group assignment or divide them into pairs to do something that will help them think about the problem that they were having problems with. So ask them to look at a particular kind of example, or do some other kinds of things that get them thinking in the right direction without necessarily giving them a hint or telling them an answer. And I certainly won't say, well, I'm going to give you something that's going to help you do that problem, right? They may eventually figure out that it might help them do the problem, but I'll say, oh, we're going to do this activity since you don't have that. And so if I haven't taught the course a lot before, I might not know, but I might suspect that there are some problems that are harder than others that might lead to some difficulties. And that's if nobody has anything at all to present, obviously. If there is a problem that doesn't get presented, if it's necessary for going on in the sense that they're going to have trouble with other things until they crack a particular idea, I would also try to get something moving so that they're thinking in the right direction. But otherwise, I might just let it lie. I guess that wasn't really part of your question, but sorry.
And by the way, when students don't have anything to present, I just want to make this comment that it's not necessarily a bad day in class. No. And in fact, some of the best days in IBL classes are when people are stuck on something. So just throw that out. So that was nice. Thank you. Question 4, Brian. When do you know to step in or to let a discussion continue?
Okay. So I'm going to cheat and answer all 4 of the previous questions. I think one of the things that scares people about transitioning from more traditional authoritarian styles to IBL is they think that because they're not the one generating much of the material day to day in class, all they can do is respond to what the students bring with them. And I think if that's all you're doing, you've probably lost, right? You're too far behind. And Carol made this point already. She knows where the errors are, where the struggles are going to come from experience, and that's one of the great ways to get at it. And so she has a plan beforehand. So I select presenters based on, well, I think of it as sort of 85% likely to get this right. I don't want 100% because my goal is not for the right thing to be said in class. If that's what I wanted, I would say it. My goal is for us to have a useful discussion. So we need to get data about what they need and what would be a useful discussion for us to have. So in terms of stepping in, it's always filtered through this frame of what are these students able to handle? I decide, how are they feeling this week? Do they seem to feel a little frustrated with the class? Then I'm gonna step in a little bit earlier because I'm gonna manage sort of the emotional aspect of what's going on. Or do I think anyone in this class is really going to make this connection today? Or how close are we to the end of class? Or how's that gonna affect how they feel about this? But the real answer to the question about stepping in is I jump in, I ask them questions. I sort of, as somebody said yesterday, actually I think it was Jonathan Hodge said yesterday, I sort of play a naive role. I'm like, oh, what's going on here? Tell me about this. You, the one in the group who's not talking much, what are you thinking about during sort of group work at the beginning of class? And I keep asking questions until they realize that there's a tension going on, and then I kind of smile at them. They realize that this smile means now you've found something interesting to think about, and then I wander away. And at like day 1, they think I'm evil, and after that, they think they understand. And my colleagues in the department struggle with this a little bit. They don't really understand quite what I'm doing, but when my colleagues from outside the department regularly praise the sort of ability to walk away right when the students are asking that last question, like, no, now you are ready to answer it. So I don't know if that's specific enough to be helpful, but that's how I think about these things.
All right, very good. Thank you, Brian. Okay, so what we'll do now is to open the floor. It's an open floor now, so for every person, there's a ball around you. Okay, so the only thing we ask is don't shout out. Wait for a microphone, and then we'll get going. We have plenty of time.
While the mic is going, is this on? Can you hear me?
Yeah.
Okay, while the mic is going to somebody, oh, there we go. Can I say something quick
Sure.
here? I think one of the things that's important to know, and when we start answering these questions, these are not canonical questions, that if different ones of us were answering them, we would probably answer them in slightly different ways. And I think that what you need to take away is that talk to a lot of people about how they run their classroom. This is not about what rules make this work, right? This is about big picture ideas and big picture goals for our students. So.
Great, thanks. Thank you, Carol. All right, so there's a question here.
Hi, is it working? Hi, this question is for Lee. I heard your answer about how you want your students to talk to the student privately and ask, be inquisitive, what's going on? Why don't see you participating that much? Now, when you do that, do you email them, or do you tell them to come see you, or you wait when everybody's leaving and then you try to get hold? What is your process to kind of being able to talk to that particular student privately? I'm curious to know that.
I try to catch the student right as class is ending and ask her or him if she has a few moments right then to talk with me. If she doesn't, then I'll say, could we make an appointment for you to come visit me in my office, and then we'll do it. Or she might say, well, I'd rather text you or email you, and if that's the case, I'll adopt whatever mode of communication she or he wants. But my first attempt is always one-on-one right after class, when maybe her or his feelings are as close to the surface as they're going to get.
Hello, I'm Rachel Schwell at Central Connecticut State University. I've taught IBL twice now with 2 different class sizes. One was the first time was about 15, which was just perfect. The second time was 33, which was not optimal, obviously. So my question is, when you have, for example, a class that large and you have someone presenting at the board who is presenting maybe one of the easier problems or is progressing through the presentation at a very slow rate, and there are many other members of the class who already know the answer, they're getting bored, they're getting restless, some of them want to get up to go to the bathroom. How do you deal with that? Because that didn't seem to happen in the smaller class, but it did happen in the class of 33.
Some moderately big ones.
Okay, good, there you go, Brian.
So one thing that's changed from the way that I moderate the classroom over the last couple of years is that I usually spend the first few minutes with group board collaboration, where they get started on the theorems that are going to get presented that day. And it does a couple of different things. It allows me to give a little warning to the quiet students that we talked about earlier. I can say, oh, you're working in this group. By the way, I'm going to ask you to do the presentation, but they've just been supported by a discussion with their peers. But I can also go around, and if a bunch of different groups are talking about the same theorem, and I know it's not going to be, if it's going to be too slow for one person to present, I get information about that, so I avoid the issue partially. And the other one is because if it's about the weaker student having a successful event, which sometimes it is, I can make sure, maybe sometimes I say, okay, presenters stay at your board and the rest of you rotate one unit around, and they get a really quick version of the practice one. And then when it's the whole class, they're much more practiced, they're much more ready to give, they understand what they need to say and what they don't. So I guess, like I said earlier, if you wait till it happens, a lot of the times you're out of options. So these are some of the things I do to prevent that from happening.
Anyone? So Lee and then David.
Rachel? Yes. Let me ask you a couple of questions about the situation in which that happened. What was the course?
It was discrete math, or sort of our transitions class.
Yeah, okay. And in that class, do you customarily have just one person at a time go to the board?
Yes. Yeah.
Okay. in a class of that size, I would be tempted to let more than one person go to the board at the same time, and if there's room, put their work up, and then when everybody is through with the board putting the work up, sit down, and then go to the people one at a time and have them explain. Doing that, you can give the people who need to go to the bathroom or who are bored a chance to walk out in the hall for a couple minutes maybe, and you can still cover a lot of material that way, but you can still give each person a chance to actually present his or her work.
David?
Well, what I was going to say is sort of a subset of what Lee just said, but I think for a large class that is a problem, and I think that having several go at once when that's appropriate is a good strategy. But the other thing is that you really do want every student to get to present. So the weakest student may be presenting something that everybody else is bored with, but the weakest student gets a chance to present too.
Okay. My name is Vinton Geisfeld. I'm from the International School of Minnesota in suburban Minneapolis. And my question is this. Usually when I split my students into groups, I find that they develop their own authority figures. One member of the group is looked to by the other members of the group as the one who really knows how to do the problem. And even if that person isn't ultimately the presenter, he then tells the presenter what to do. How do you counteract that?
All right, so this is a good question about individual accountability. So now, panelists, maybe we'll go to Carol.
I think I might be more careful about the way I put the groups together. The people that have sort of strong personalities that they're going to want to impose on other people, put them together. So that helps. I think I know a lot of people who form groups and various things. They want to put strong students together with weak students because they say, well, this helps both the strong student and the weak student because it makes the strong student really articulate their ideas to the weak student who's having trouble. But I actually like to have the people in my group be fairly well matched because I think that there's better contribution, and it gives the students who are going to be slower a chance to get their own head around it. If there's somebody who's going to get the answer too fast, even if they explain it to them very well, that doesn't work well, which doesn't quite answer your question, but I think part of it is to make sure that, or to as you can, try to get the groups to be put together in such a way that that's probably not going to happen.
In a course such as, say, discrete mathematics, I try to avoid partitioning my students into groups until the class has been going long enough to give everybody a chance to have gone to the board maybe once and had a success, so that you don't have as much of this caste system forming, the Sharpies versus the Dullies. Everybody is seeing that he or she can do something and has developed enough self-confidence that is not going to allow himself to be buffaloed by some strong personality.
All right, so I'll just add to the comment. So Todd Grunmeyer had he talked in the new user panel yesterday, and he said that when he assigned the groups, he would make sure he would pick randomly who's going to present, but the whole group's job was to make sure everyone understood it. So that's one way to sort of enforce it. And then we had the group composition issues, like you have mixed the students, and you can also change the size of the groups. So you can go down to 2 to kind of put more pressure on each individual. So, and then we have the other, the Lee's suggestion as well. So that's good.
And not any one of these. Hello? And not any one of these suggestions is going to work for every class or every set of students.
Right.
You have to try different things.
Right. So at least you have some ideas now. Good.
I'm John Bales from Tuskegee University, and I teach our 505 analysis class. And we have sort of the opposite problem of Rachel. I typically have 2 or 3 students in the class. I've had, the most I've ever had is 5 students. This last fall, I had exactly 1 student in the class. And trying to teach it on an inquiry basis, I'm wondering if anyone else has had that problem of a small class and how you meet the obvious problems that come up. For example, it's very frequent that no one has anything to present. And so sometimes I'll try to get someone up to the board anyhow. But if I do that too much, then I find that when no one has something to present, they're absent that day because they're afraid I'll call on them anyhow. So it presents unique problems. And and by the way, the head of our department wanted me to let it be known that we are hiring for the fall. So I've dispatched that obligation also.
I can try to give an answer, and maybe others will give other answers. And I think that is a difficult question because the numbers that you're talking about are challenging. They're challenging in an opposite way from large numbers, but they are still challenging. I can tell you the thing about the one student, because I had several more method courses, and I was the kid who always had something to present in the earlier ones. And when I was a senior, I took an independent study in which I was doing in sort of point set topology, which I was doing by myself. And I can tell you that it didn't work as well for me, even though it wasn't that I was relying on other people, but that the communication with other students, I think, is really important for sort of getting thought processes going well. So part of what you can do is sort of I don't know, try to get that communication going with you, which would help, I guess, a little bit in that way. My professor, and some of you know Robert Esslinger, was the person who sat in the back and said, and so, but when you have two or three, I think I would actually get them trying to work on things together, having a lot of things prepared, such as I was suggesting before, where you put an example in their way, or just have more easy problems, right? So I think it's really hard to underestimate the importance of having a lot of problems that are really accessible, that the students are really going to get. And if you say, well, everybody will just get that, it won't be a big deal, then there's a tendency to say, well, why should I waste my time on that? But I think having students having continual success is important, and you can have those easier problems really be food for thought for other things. So,
good. Yeah. So you're suggesting, playing the role of the students that are missing. You could kind of be several voices in the classroom, and also, changing your curricula, the problem set, so that you could, provide more opportunities for students to get more successes and generate more discussion. So that's nice. David?
Yeah. Just another thing I've done. I don't have this problem very often, if not enough students, but I have worked with one or two at a time, and as independent study courses, and so this does come up that there's just you exhaust what they've done, and often what I do is I talk with them about the context of the problems and the background to it, and so this isn't hints to how to solve any problems, but just background to it and context of it and why it's interesting. And usually you can fill up a lot of time that way.
Great. So I guess we'll go over. Oh, okay, we'll go there. You're deferring. All right, so go ahead. Please tell us your name.
My name is Melissa Carter from the University of Arkansas, and I may have missed I wasn't able to attend yesterday, so you may have talked about this before. I'm heading into a high school setting where there is no inquiry-based learning in general. So I'm just curious, what would be like your best advice for somebody who's going to try to start an inquiry-based mathematics program at secondary or even collegiate level, just trying to get that going, where to start, who to talk to, and
all right, Lee.
Is Lee Mahavier in the house?
Yeah.
Do you want to handle that? I mean, I don't know of anybody who'd be more expert on that than you.
good thought.
I'm Lisa too.
I would go into the Oaks room and pick up the from the table that says something like introduction. I think when you walk in the room and make a sharp left, it's your first table, especially articles by Parker and my father, William S. Mahavier, or if you're a younger than me person, pick up a CD or whatever they call those flat things. Just if you take paper, you can. Well, I guess I can't even say that anymore. You can read it on the plane because everybody has their iPad and everything with them. Anyway, that's the first thing I do. Same thing I do is I look around the room for the oldest person you can find That might be Miss Lyda Barrett. It might be Dr. John Newberger. It would certainly be Dr. Worrell. Can those people please stand up? Okay. Okay. And have a short conversation with these people, and then they will direct you to other people like a tree. Mm-hmm. And if either of these things falls through, my name's Lee. I'm easy to find.
Mm-hmm. Great. Thank you, Lee. I also want to point out, AIBL, we have a mentoring program, and we have some mentors and mentees who work in the high school. So that's a great place to start and to get going. K-12, you have different challenges than college, and I just want to also say thank you for being here. It's great to see some high school teachers here. Anyone else want to?
I was going to say we have a number of people from high schools who are here who might stand up and be people you would talk to.
Oh, that's right, with the geometry project, which I thought of and then I forgot just now. Okay, where are they?
High school teachers, please stand up.
High school teachers. All right, thank you. So there's a round table for this later this afternoon, right there. All right, okay, we'll go to Allison, yes.
So I'm Allison Marr. I teach at Southwestern University in Georgetown here in Texas. And I have a question based on a comment that David made about you end up having sort of the stronger students work the harder problems and some of the weaker students work, you know, some of the sort of easier starter problems. And so, but they end up doing the same amount of problems generally. And I had this, you know, situation in an IBL class that I ran, and my issue was then evaluating that and trying to decide, and the students start to realize it too, like, well, I know that Susie's gonna work all the hard ones, so I'm not gonna attempt those. So it's sort of a twofold question of how to push those students to work harder problems, and also, in the end, when they're all working about the same number of problems, how do you evaluate that difference?
Okay, well, a significant part of my grading is their presentations, so that's an important part of it. And in the end, it's not all the same number, but I just get them all actively participating. So they understand that part of what they're supposed to do is present, and that it's part of their grade in some vague way I don't really specify. But what that means then is that they do try to present as many as they can. And then what they realize is if you want to present, you have a much better chance of being picked if you present a harder one. So then there's a natural motivation to try to do that. So I think they all try, and they get engaged in it, and they really get a lot of satisfaction out of success. And so if they can succeed at doing something harder that other people couldn't do, they're highly motivated to try to do that.
Can I? Oh, go ahead.
So I have two different responses. The first is that essentially all of my students write down proofs for essentially everything. So they're all writing. They may not all be presenting, but they all are writing. This is also a partial response to the tiny class. I think student standards for what they think they understand about their own idea are too low unless they write them down before class. So one of the ways I avoid the class where nobody has anything to say is if they've written something down, worst case scenario, they say, well, let's start from where I was starting. But lurking in the background is my least favorite four-letter word, fair. And I just think the word fair is nonsense. That I cannot decontextualize the way that I evaluate my students from what they need. And I mean, you can tell from the first three words of a proof whether or not they understand how it's supposed to start and whether or not it's going to be very well structured. And that influences the way that I grade it. And so I let my grading be relative to what they need to grow as human beings, and I don't let that stress me out. So as long as I've never had the problem where they avoid doing the hard ones, but as long as they appear to be doing work that's about, that's proximal to what they can handle, I'm perfectly fine giving them A's. And I usually give pretty high grades, and I get perfect 5s on the workload, 5 out of 5 on a high workload in my classes. And I'm perfectly comfortable with that.
Can I address this too? I do pick my my presenters similarly to the way David Clark does, but I don't ask them ahead of time who has it. I go to the person who's presented the least and I say, do you have one of the problems for today? So they actually kind of get singled out in a little bit of a way, though if they say no, that's okay. There's nothing wrong with that. So to some extent, they're going to have to look me in the eye and say, you know, the only ones I ever got are the easy ones. And that there's a bit of a deterrent there. But I also have take-home exams that I give my students, and they have to prove theorems that they have never seen before. And so the students that prove only the hard theorem, you know, only the easy theorems in class and don't really attempt the hard theorems, whether or not they get them is a different issue, of course. But if they don't really, if they're really not attempting the hard theorems, that does take care of itself on exams, and the grades turn out beautifully. I've never had a problem with that.
Right. So I think this is a great question about assessment, actually, and how do you go about it? And I think individuals have different environmental factors that where you have to deal with it. And I think it's important to, I'll just point out that assessment is a big deal. There's quantity, there's quality, and then how do you go about that? We can have some rubrics perhaps put on, made available on the AIBL website, so that way people can start thinking about how to evaluate presentations and other things, so we can get that going. All right, so are there other questions? So,
Can I, while they're taking the
right. So Susan back there.
While they're taking the mic, I'd like to say one thing about evaluating. By the way, I don't evaluate the presentations in class. I don't make any attempt to do anything other than keep track of who's been to the board when and what they presented. They might get a little bit of a bump if over time they present a lot of hard problems. But what I have found is that the single best predictor, I've tried all kinds of schemes over my lifetime, by the way, for evaluating presentations, having students evaluate presentations, all kinds of things. The single best predictor for how well they do on the take-home exams is how many times they went to the board to present something. And so I learned just to keep track of that. And then they know, actually, that there's no penalty for going to the board. If they go to the board and they present something, they're going to get the same credit sort of regardless. And it makes it a very safe environment.
Okay.
Ready?
Susan, go ahead.
All right. So I taught an IBL class for Intro to Proofs, and I think my next class that I'm undertaking is not going to be proofs-based. So Calc 1, Calc 3, something like that. Could you all compare and contrast what the biggest difference you think I'm going to have in either students or preparation of materials, or just, I guess I'm asking for what I should be aware of that's going to change the most?
You have to support them much more thoroughly in the way they communicate their ideas. Otherwise, it'll remain disconnected. I think POGIL is a great model for something like that.
I would say one of the things that changes a lot is the audience. When you teach an Intro to Proofs course, it's primarily students who are seriously thinking about taking mathematics as a major or a minor. And in calculus, of course, it's a much broader audience. And you have to, I think, therefore, you get a wider variety of different learning styles. You certainly get different kinds of interests, and that has to affect the way you do things.
The biggest difference for me between a proofs course that has maybe 15 or fewer students in it and, say, a calculus course which might have 25 students in it is in the proofs courses, I always keep a diary. While the student is at the board presenting, I'm sitting in my chair with my smart pen making notes on what that student is saying. If you haven't heard of a smart pen, by the way, check them out. They're revolutionary for doing more style courses. After class is over, and I try always to have my schedule such that I have no two classes back to back, I go back to my office and I transcribe my notes that I've taken in class onto my word processor, where I have an actual diary of everything that went on in class in a given day. What the theorem was, who attempted to prove it, whether that person was correct or not, whether it was discovered that he had a mistake by the rest of the class, and so on. And whenever a student wants to know how he or she is doing in the course, I can give out a number usually, but I usually will say, well, if you'd like to get a really good idea of how you're doing in the class, let's go back to my office and we'll just search for your name in the diary, and we'll see what the comments that I made about you were each time your name came up. And I'll have to censor some of my comments that I've written down in the diary. But most of the time I don't. And I think most students who come in who will screw up their courage and come into my office and hear that news will leave the office feeling a lot better about themselves than they felt going in, because like Brian, I can see that although student X is maybe not coming into class with as good a background as student Y, student X is really making progress in how he is building on what he brought in. And I can usually put that down in the notes, and the students can see that they are they're having success, even though they know that there's further for them to go. In the class, when I'm not, like a calculus class, I'll just record a number by each student's presentation. 0 if he didn't show up, 1 if he came and that's all, 2 if he said something from his seat, 3 if he went to the board, even if he failed miserably, 4 if he went to the board and did beautifully or made some fantastic comment from his seat. And that's like a GPA, so you can actually tell the student what his or her class GPA is when the person wants to come see and talk about his work.
Okay, so let's go back to the issue of lower division versus upper division. So proof-based versus non-proof-based. Any other comments from the panel you want to make? All right, so before we get to Harry, so just kind of recapping, there was the variance. You mentioned is class variance is greater. They come in with wider backgrounds. You also have less control of the content often in calculus for the usual reason. So it does change the game. We do have people who do teach calculus, and Karen Ray was here, so I would say we should start a discussion after the panel session on that. All right. Harry, nice to see you.
Harry Lucas, retired. I'm emboldened to answer the last question with my question, because the status of our table here is improved with Rob Kirby being present. So the last question was what changes the most in the two systems, I believe. Well, the first day of class is what I was going to ask about. And we need some discussion on that, I think. Maybe Ted Mahavier or Mike Starbird in addition to the panel. Thank you.
Okay, so the question is, what do you do on day one? All right, so here we are.
Can I answer that question?
Yeah.
Well, the first thing I think probably you'll get universal agreement about this. The last thing you want to do on day one in an IBL course is go in and start talking at them. Because that sets things very badly. So for me, I go in, I say, here's the link to my syllabus online. You can read it and ask questions about it next time. Okay, on to the math. And I hand out something for them to do day one. They're working in class on something related to mathematics from the very first day. I may or may not get somebody to come to the board. It sort of depends on what that is on the first day, but they're definitely in class working on math pretty much from the first seconds of my class.
They all have to stand up. They all work. They all stand. We're at the boards. I have a lot of whiteboard space, which is awesome. But they must stand, and I too give out the syllabus at the end and say, we'll talk about this at the beginning of class tomorrow. Think about it over the next 2 days.
On the first day of class in discrete mathematics, I have everybody come to the board, and as many as can come at one time. And each one is supposed to put up on the board an example of a finite set, an example of an infinite set. And I tell them, by virtue of the fact that I'm making you come to the board here on this first day of class, each one of you has already earned a 3 out of 4 for your first day of class. And that seems to really do a good job of breaking the ice and getting them to see that you can walk to the board and live.
I mean, look at us, right?
Yeah.
We're still here.
And I sometimes will tell them about my wife, who has a master's in mathematics and is a software engineer at NASA. The first trip she made to the board in a math class, she fell over the trash can. So you can have ignominious beginnings and still go on to great things.
All right.
In the first day of a proofs class, I will, like Carol, probably put up on the document camera 3 or 4 pretty nice, little easy number theory theorems, whether I'm teaching number theory or real analysis. And I'll give them about 10 minutes to work on theorem 1, and then I'll see if I can get somebody to the board to present an argument on Theorem 1. I think I always have been able to do so, and I've also, I think every time the first student has gotten it right. And then, and the rest of the class certifies it right. I don't have to say, that's correct, now let's go on. Then we'll usually get to 2 more theorems maybe, and we'll usually get at least one person to the board who makes a mistake, but who is either able to correct it or somebody from the room will correct it. And it doesn't seem to destroy the person who made the mistake, and it really builds up the student who found the mistake. And by the end of the period, at least everybody has seen 2 or 3 students go to the board, maybe one succeed, the other one maybe not succeed the first time, but they all see that going to the board is the important thing, not necessarily succeeding the first time. But this business of breaking the ice and getting them out of their seats in the first day of class is really, really important.
Yeah, I think what I do is consistent with all you've heard, but what I don't want to do on the first day is talk about an overview of what they're going to learn about. Instead, what I want to do is I want to get them interested in problems and talk about some ideas and questions as quickly as possible and start a discussion about those, and if appropriate, have somebody come to the board with ideas or just discussion. But at the end of the first class, they see that this is a course about solving problems and perhaps proving theorems, answering questions, rather than learning a lot of stuff that I'm going to say.
All right, thank you. So that's good. So establishing the classroom culture as an IBL class from the get-go. And so this implicit, so Jonathan Hodge brought up yesterday in the banquet talk about how students may not know their role in an IBL class when they walk in, because everyone has sort of default expectations. So then these activities are designed to get them past that, I would say through activity. And there are instructors out there who also take a few minutes to say, okay, here's what we're going to do and why we're going to do it. So it's sort of a direct marketing approach in addition to the implicit marketing approach. All right, good. So thank you. Thank you, Harry, for that question. All right, so we have a question over there in the back.
Columbia University, and my question is about variants of IBL in particular. While I was an undergraduate at the University of Chicago, as a senior, I participated in a number of courses where the students were also responsible for preparing scripts for other portions of the class. So we were broken into groups, and some portion of the material we were working through the scripts prepared by our classmates, and some portion of the material we were working with literature to prepare scripts for our classmates. And I was wondering if any of the panelists had experimented in this way or were aware of other places where that was going on. Thank you.
All right, thank you. Great question.
No.
Yeah. Does Ed Berger do this? I think.
Mike, do you know if Ed Berger does this?
I don't think so. Okay.
I've never heard him say so.
Yeah. All right. Sorry, Ed. He's not here, but sorry.
Could you elaborate on what scripts are?
No, it's
theorem sequences.
Yeah. It's
just their word for it.
Yeah, it's a Midwestern dialect. I'm from California, so we don't use that term. Not that we're against it. It's fine. Yeah.
The closest that I ever get to that is that in almost every class that I teach where we do a little bit of theorem proving, somebody will raise a conjecture. And usually the conjecture is worthy of having that student's name attached to it. And so that becomes a part of the overall class's script. And so the next time we get together, we'll say, okay, anybody have Theorem 14? Okay, no. Well, does anybody have Melissa's conjecture? Counterexample, proof. So we sort of develop our own scripts, but not in as formal a way as apparently your classes did.
And then your question about variants of IBL, it varies quite a bit. It depends on the course and the environment, and those are the drivers. And
the instructor.
And the instructor as well, and their experiences. So I would say that you would see quite a wide variety if you sort of pulled this room. All right, so last question, Elizabeth.
Hi, I'm Elizabeth Thorin. I'm at UCSB. I am teaching, I teach differential equations courses for honors students. And the problem I have is that this is below proofs level. And I'm struggling with getting the quality of their presentations and arguments to be good. I feel like at proofs level, there's sort of a clear line of demarcation, what's correct and what's not. And I have something in my mind for what the quality of their presentation or argument should be, but I'm trying to get the students to feel that something is too glib, and they don't. They're kind of okay with, meh. Like they understand, the student obviously understands, let's move on. And I will say too glib, but I don't want to be the one saying too glib. I want someone else to say it.
All right, very good question. I guess David and then Lee. Yeah.
Go ahead.
Yeah.
Yeah, I guess in that situation, I would try to phrase questions about what they put up there, like what's not clear about it, or what's not explained clearly. What questions does it leave open? And so that they see there's more to do than just what they've said.
Find out the holes. A challenge to the audience to find the holes in your presenter.
Yes, or if they don't find it, if you can ask questions, phrasing it as questions of, you know, what hasn't been settled here about the problem.
All right, so questioning. Lee, yes?
How free are you to choose your materials for the course?
100% free.
Okay.
I write them.
He's not here at this meeting, but Ed Parker has made a career out of teaching and studying differential equations. He held my hand for the last time I taught differential equations at my university through the whole semester. And if you get in touch with him, and his brother Elwood is here at these meetings, and I can give you his email as well. And all it takes is one email from you to him, and I think you'll be off and running.
Great. That's a great suggestion. Also, I have a colleague who would collect solutions and then to have the class try to improve them in some way. So if you feel like the solutions are glib, it could be that they need to recycle through the thing and say, look, is this airtight? Are there ways to make it better? That could be a great activity. And I have a colleague who does that in these situations where he's just not satisfied with the language. Lower division is tough because you don't have an established language set. And you run into this in calculus too, which goes back to Susan's topic. Because there isn't a formal language, you get into these gray zones. Yes. Sorry.
Most often in class is, can you say that in your own words? I mean, that's like 30 to 60% of what I say, depending on the day.
Really?
Is, yeah.
Okay. Just kidding.
It really brings to mind that they can't say, they don't really understand.
I think it's also important to reiterate what was said before about this, and that is that they just don't have the kinds of articulation skills of mathematical ideas that students at a higher level do. And so you got to work on it little by little and be very, very patient, right? Not expect that, oh, well, it's going to happen overnight. It's you want to see an arc over the course of the semester where things get bigger by modeling things and by helping them to improve on them that way. So be patient is my suggestion.
Right. So I think the theme that's coming out is, can you restate, reformulate the ideas? You know, Brian said, I asked this question a big chunk of the time. We need you to rephrase this in your own words, and that's great. I think we're out of time. Is that right? So what I like, let's thank the panelists. Thank you very much.